Okay, so here's the plan for today. I want to talk about. Go ahead and close this up. I'll let you get back working on some things here in a second. I'm going to have you do a couple of these on the new assignment to get it reinforced. So we want to look at least common denominators of rational expressions. The goal here is this is leading up to adding and subtracting rational functions, right? Where rational functions just being polynomial divided by polynomial, right? So let's think about this first of all in terms of numbers. Okay, so what if we had something like this? Like let's say we wanted to add up 9/10 plus 11/15. You all could do that. What do we have to do to add fractions? Common denominator. Good, so you know that. So what would the common denominator be? 30. Okay, now how'd you get 30? You're right.
They both go to 30.
Okay, so
It's a first and second.
say it again.
First number they both go into.
First number that they both divide into evenly, right? So that's what we're looking for. When we say least common denominator, what that really is the least common multiple of the denominators, right? So in your head, you probably did something like this. If we made a list of all the multiples of 10, it would just be 10, 20, 30, 40, etc., right? If we made a list of all the multiples of 15, we get 15, 30, 45, etc. And the first one we get that shows up in both is 30, right? So that's one way of thinking about it. That works. That's a good model for doing it with numbers. Numbers are easy for you guys. You've had a lot of practice with it, right? What about, let's look at me. Oh my gosh.
Answer it.
No, I'm not answering it.
You're bad. Let me answer.
So here's another way of doing it. Here's another way of doing it. What if, let's think about this in terms of, the prime factors of the denominators. So another way we could do this is we could say 10 breaks up into a product of what prime factors? 5 and 2. Okay, so 2 times 5. What about 15? 3 times 5. Okay, so we need the least common denominator to be the smallest product of those factors that's going to include a 2 and a 5 and a 3 and a 5 at the same time, right? So what would that list be? 2, we need a 2, right? So there's my 2, that accounts for that one, right? Times what? I need a 3, good, because that includes that. And then what else do I need?
5.
A 5. I don't need to multiply 5 twice, right? Because 5 is a common factor, it's shared by both. So when I include a 5 in the denominator, that's accounting for that 5 and that 5, right? Does that make sense? We just want the smallest product that's going to check off all the boxes for each denominator, right? It needs to include a 2 and a 5 because 10 has to divide into it. So it has to have the same factors that 10 does, 2 times 5. 15 needs to divide into it. So it has to include a 3 times a 5 in there, right? But as long as the 5 is already showing up, I don't need to multiply again, right? So that's how I get my 30. Does that make sense? Okay? So, all right, so we're good, right? So that's how we do it with numbers. Now let's focus on variables. How can we do this with variables? It's exactly the same concept. So let's take this denominator. First of all, let's just find the least common denominator of these two fractions, right? So let's take the green denominator and break that up into a product of factors. Okay, what do we got? What does that factor into? Well, how am I going to factor that? I can take a 3 out. That's all I really can do here is factor out a greatest common factor. And I have 2 terms like that, right? So we can take out a 3, and what are we left with then? X minus 5. Okay, that's as far as we can go, right? X minus 5 I can't do anything with. Okay, so there's my green denominator. Now let's just separate this. What about if I factored the yellow denominator? What am I gonna get there? I can take out a 4. Now what am I left with? X plus 7. Yeah. Okay. Good. All right. So then we've got to build the smallest product that includes all that stuff. Are there any shared factors? But X is not a factor, right? What are the factors here? Factors are the things that are being multiplied, right? So in this case, I've got 2 factors. I've got a 3, and then I've got, it's in parentheses, so that's one big factor, right? X minus 5. And then I've got another factor over here that's a 4, and then an X plus 7. Are any of those shared? There aren't. There are no shared factors, right? We can deal with the numbers kind of separately. So what's the least common multiple of 3 and 4? 12. So we get the 12, that takes care of those, right? But then there's no shared factors. So I'm just gonna have to multiply by both X minus 5 and X plus 7. Everybody see that? So this is my answer. Okay, that's my answer. That's the least common denominator for this problem. Okay, let's look over here. How about if we look at this one? So let's do this guy. Okay, what are the factors of that? Now that's a trinomial, right? So we're going to use all our old strategies for trinomials. In this case, I have a 1 in front of the x squared, so we're just looking for simple magic numbers, right? If this factors, it's going to factor into something like that. So what are they going to be? 7 and 4. Not quite. So it's negative and negative, that's right, because they multiply to a positive and add to a negative, right? 8 and 3. I know you guys know one. 8 and 3. 8 and 3, okay. 8 and 3. Okay, good. Everybody get that? Magic numbers multiply to positive 24, add to negative 11. Okay, what about over here?
3 and 3.
Yeah, 3 and 3, right? Negative 3 and negative 3. So I get x minus 3 squared, or if I want to write it as, just for now, let's write it as x minus 3 times x minus 3, okay? So now let's build the least common denominator from those factors, all right? So we need an x minus 8, right? Because I've got an x minus 8 factor in this one. Okay, that takes care of him. What next? Okay, I need an x minus 3, so that takes care of the green denominator, right? The product of those two is going to include that whole denominator. But the x minus 3 also takes care of one of those, right? What else do I need? I can't just have one x minus 3 because over here the denominator is x minus 3 squared, right? So would everybody agree I need another x minus 3 there to take care of that one? Yes. But the important point here is that I don't need 3 of them, right? Do you see this? Everybody focus on this real quick for a second. I've got, if I look at both the green and the yellow factors combined, I've got 1, 2, 3 factors that are equal to x minus 3. I don't need them all though, right? I just need 2 of them. Because by having 2 of them, I've more than covered my bases here, didn't I? Right? I've got enough factors to build x minus 8 times x minus 3. But I also need x minus 3 times itself. So these two go to that one. These two go to that one. They just overlap in the middle, right? Because they have a shared factor. They have one shared factor. Every time you have a shared factor, you get to make your common denominator a little bit smaller, right? So that's my answer for this one. Okay, now you guys take a quick second and just try that one. Okay. Try that one. So we've got to factor both of those denominators completely. Scratch paper on the Chromebooks? There's scratch paper right here if you want some. There's a bunch of it. You all right?
Huh?
You okay?
Yeah.
Okay, so real quick, you may not be done, but maybe we at least, you gotta start maybe. So let's factor the green denominator. What's the first step? Okay, meaning I'm gonna factor out a 3, right? I wanna always factor out a greatest common factor. So I can take out a GCF of 3, leaving me behind what?
7.
Can't forget this one, right?
Yeah, x squared.
So I get x squared, and when I wanna figure out what's left behind, factoring means dividing. If I factor out a 3, I'm just dividing each one by 3. So x squared plus
7x plus 2.
7x plus 10. Good. Okay, good. Okay, now how about over here? Yellow one. What's my GCF there? 5, leaving me what?
X squared plus 4x minus 4.
Plus 4x, good, minus 5. Okay, but we're not done, right? We got the 3 out front. Now we can see if we can split apart the trinomial. Okay, so I've got a 3. Can I do this?
Yes.
What do I get for my 2 magic numbers?
2.
Okay? How about over here? I've got my 5.
Negative 1.
Can I split the trinomial apart?
Negative 1. Yeah. Negative 1.
Okay, negative 1 and 5. Okay, so everybody stop what you're doing now. Take a look. Let's see if we can build our LCD from this, right? We want our least common denominator from both of those factored denominators. So first thing, what about the numbers? What's the least common multiple of 3 and 5? 15. Okay, so we can take care of the 15. That accounts for both the 3 and the 5. They both divide into that, right?
Yeah.
Okay, what about, what's a factor I need to include?
X plus 2.
Okay, I need an x plus 2 because that shows up in the green denominator. Okay, it's not a shared factor. What else?
X minus 1.
X minus 1 shows up there, so I need it.
X plus 5.
And then I only need 1x plus 5 because those are shared factors. So that's my answer, right?
You said this was easy.
Yeah, I mean, it's not too bad, right? I mean, you can leave it like that for now, right? Eventually, you're gonna have to multiply some things out, but, so here's what I want you to do then. At this point, I want you to open up the 9.1 assignment and do the first 2 problems. First 2, that's it.
9.2.
9.1.
I was like, yeah,